Cords connect electrical devices to power sources and extend the reach of electrical power outlets. They also power tools and appliances. Caps protect the ends of electrical wires from damage, prevent accidental contact with live conductors, connect multiple wires together, and terminate wires in electrical boxes. Bodies house electrical connectors and components, provide insulation and protection from electrical hazards, secure electrical connections, and allow for easy access to electrical components for servicing or repairs. Cord, caps, and bodies are essential components in various electrical applications. Power cords connect electrical devices to a power source, such as power cords for computers, lamps, and appliances. Indoor power distribution involves distributing electrical power within buildings using extension cords, power strips, and other multi-outlet devices. Electrical wiring is connecting electrical components and wires within electrical systems, such as switches, outlets, and junction boxes. Machinery and equipment utilize cord, caps, and bodies by providing electrical power to tools, machinery, and other equipment. While cord, caps, and bodies are widely used in extension cords, there are some limitations. Firstly, ampacity. Extension cords have a limited current carrying capacity, which can limit the power consumption of devices connected to them. Secondly, length. Extension cords can only be used for relatively short distances, as excessive length can cause voltage drop and safety hazards. Thirdly, outdoor use. Extension cords without proper weatherproofing may not be suitable for outdoor use, as they can become damaged or create electrical hazards in wet or harsh environments. Therefore, it is generally recommended to use cords, caps, and bodies for indoor power distribution and for powering specific equipment, rather than as a substitute for permanent electrical wiring. Ampacity refers to the maximum amount of electrical current a conductor can carry before sustaining damage. Factors like conductor material, size, insulation, and ambient temperature influence ampacity. National Electrical Code or NEC Table 310.15 details allowable ampacities for various conductors under specific conditions. Exceeding a conductor's ampacity causes overheating, which degrades insulation and increases the risk of fire. Circuit breakers and fuses protect circuits by interrupting the flow of current when the ampacity is exceeded. Voltage drop is the decrease in voltage that occurs along a conductor due to its impedance. Longer conductors and higher currents result in greater voltage drop. Excessive voltage drop impairs the performance of electrical equipment and causes overheating. The National Electrical Code, or NEC, recommends limiting voltage drop to a maximum of 5% for branch circuits and feeders. Using larger conductors minimizes voltage drop. Electrical safety involves protecting people and property from electrical hazards. Insulation prevents contact with live conductors. Grounding provides a path for fault current to flow, tripping a circuit breaker or fuse. Ground fault circuit interrupters or GFCIs protect against electric shock by detecting small imbalances in current. Overcurrent protection devices like circuit breakers and fuses interrupt the flow of current when it exceeds a safe level. Regular inspections and maintenance of electrical systems ensure safety. Always de-energize circuits before working on them. Use appropriate personal protective equipment, PPE, such as gloves and safety glasses. Follow the National Electrical Code, or NEC, and other relevant standards.